Advanced Higher Chemists, this one is for you. Let's have a look at how we can use valence shell electron pair repulsion theory to work out the shape of a sulfite ion. So you don't really want to overcomplicate this because you actually learned a lot of the foundational knowledge for this in National 5. So if you remember back in National 5 where you did those electron sharing diagrams, you know, the ones with the circles that overlapped. We're basically doing the same thing here, except we're not drawing it as circles this time. We've got our central sulfur atom, and then we have oxygens around the outside. Now we should know from, again, National 5 that oxygen needs to form two bonds, so if the oxygens are on the outside, they need to be making double bonds to the sulfur. We can then look at how many bonding pairs we have, so there'll be one pair of electrons in each bond. So altogether we have 6 bonding pairs of electrons around there. Then we have to look to see if there's any lone pairs. So again, you did do this at National 5, you had to look after you'd drawn in the electrons to the overlap bits, were there any extra electrons to put in? We're doing the exact same thing here. Sulfur's in group 6, which means it has 6 valence electrons. So far we've drawn in 1, 2, 3, 4, 5, 6 for the sulfur, which means we've probably used them all up. However, what we need to remember is there's actually a 2 negative charge on this group ion. So if we put it into square brackets, because that's the best practice for these charged polyatomic ions, and we put our 2 negative charge on the outside, kind of like we do for the transition metal complexes. Now this 2 negative charge means that the sulfur has 2 extra valence electrons. A 2 negative charge means 2 extra electrons. So although we thought it had used up all its 6, it actually has 2 extra, so that means there is 1 lone pair left on the sulfur. What this lone pair does then is it squishes all this down, it repels all these bonding electron pairs down to form more of a structure that looks like this. Okay, now again, if you think back to your National 5 days, what does this shape remind you of? Probably, hopefully, reminds you of the shape of ammonia, which we know is trigonal pyramidal. Okay? Just like this is trigonal pyramidal, this will also be trigonal pyramidal, even though it has double bonds in it. It doesn't really matter because it's the same orientation around the central atom. So valence shell electron pair repulsion theory really is just almost as easy as it was at National 5. You've just been thrown some polyatomic ions into the mix and some extra shapes to learn. If you would like more help with advanced higher chemistry, then you can join my advanced higher chemistry Google Classroom, which has got loads of self-marking quizzes, all my tutorial videos, and you can also ask me any questions at any time through that. If not, you can always access my tutorial videos for free on my YouTube channel. Bye!